All right. Good morning, afternoon, night, everyone. We're just gonna have a very quick seminar just to do some housekeeping stuff before we get started on today's talks. So as always, these videos are going to be recorded on YouTube, and you can find the links for the YouTube channel and the WebEx. Remember that market research and costing plans assignments are due. I think are they due by this Friday, Ian? 6th of
I think it's just check on edX site for the exact due date. Excuse me. If you're having trouble getting it in on time, please send me an email and let me know. Use the IoT Capstone Project email address for that.
Well, congratulations on completing your videos. We're just going through. I started marking some of them myself as well, about 15 of them. If you had a YouTube link, I would have posted there. If you had those comments on your YouTube link, I would have emailed you my feedback. And as soon as we are finished with marking everyone's videos, you're going to see the marks posted on your WebEx page. Now, from now on, we're not going to have that much of a seminar at the beginning of these meetings. The idea is we want to get you guys talking, especially if you're working on a prototype of your ideas. We want to helps from us, have us start talking, let's start discussion. Now, to get that started, I'm gonna go over a very, very quick introduction to sensors, very basic. So especially if you don't have a technical background, it should give you an idea of what are the sort of things you're looking at when you're working with sensors, and a couple of very simple example codes. And as we go to the discussion, I'll show you some ways if I have a new sensor and I want to start working with it, how would I go about finding source code for it, and what are some of the alternative ways when you're choosing your platform, which I hope you already have by now. So let's move on to the next bit. Another reminder, here's your mark breakdown for the different assignments we've had so far. And yes, Ian, you wanted to?
Just as I put my hand up, in actual fact, I'll just make a quick previous slide. I've had a few questions asked about the report. So I posted something up in the discussions, basically just saying that if PDF document that we created and just fill in the blanks, that's fine. If you lay it out as I've given a very minimal example in the discussion board, it might actually save you some time in the long run. If you lay it out more like the final report's going to be using own structure, you can cut and paste from that market research report into your final report and save the translation time. So it can be a little bit better. It'll also read better having a proper structure. But if you're going to use your own format rather than the PDF form, make sure that you cover each of those points: industry analysis, competitor analysis, product and service, pricing strategy, SWOT analysis, so that we can find it in the way you're writing it. People have also asked how long it should be. Roughly 20 pages is what we would expect as the maximum, not counting the table of contents if you put one in, or for each of the sections, use the percentage weighting as an idea, roughly how many be. So this is worth 10%. So it should be around about 2 pages of the document. Okay, it's up to you how you want to present the information. PDF template, there's a very brief outline that I gave in the discussion board you can go and have a look at. Okay. You're still quiet there. You're muted, Savash.
So I talked about the talk that I'm going to give today, and we can quick talk for the for your next session. So feel free to take a look at that as well. Now we're going to be running the MOOC for 2 extra weeks. So we finish in week 12, but we run it for 2 more weeks. So we finish marking, give feedback on your final reports. And let's see. And in that time, and from now on, I would recommend taking a look at the list of the faculty advisors that we have to see who would be more suitable to what you're currently doing and being in contact with them. That doesn't mean that you can only interact with only one of us. If you feel like, let's say, your IoT project has some embedded system, low, small electronics, microcontroller components, you can always quick email to me if anything to do with embedded system and more networking side. Ian and Naz would be the people to ask. Looking at GPS, spatial locationing, and app development, David would be the person to ask. And Valerie, any question about big data and probably looking at large amounts of data. And of course, Hannes, anything to do with AI, you can contact him and ask questions and get advice for your projects. And if your project involves these different topics, you don't have to just stick to one supervisor. You can send us an email and just make sure to put the name of the person you want your email to get to on the subject of your when you're emailing to the capstone email. So that way we'll all see it and respond to it as soon as we can. So with a quick introduction out of the way, Ian, do you see my other slide open now? All right, thanks, Hannes. So,
that's it.
How much time do we have? All right. So I'm gonna again, as I said, a very very quick discussion, just a general overview of sensors and how do we usually interact with them into microcontrollers. So, as a very general characterization, usually divide sensors into passive and active sensors, and that depends on what type of actual electronic component we are calculating and then later on convert it to realistic time characteristics. So if you're talking about passive sensors, it's usually a change in resistance, capacitance, or that we're calculating. So when we're talking about raw sensor data, that electronic change that we're measuring, and then we look at the data sheet and we change that calculation and we convert those changes to real life, say temperature or pressure. So active sensors. With active sensors, sensing we're sort of seeing the change in something else. The difference between active and passive sensors is with active sensors, usually we're seeing changes in voltage and current, and converting those to real-time values. So that's the main difference between active and passive. So in both senses, it usually comes down to your sensor connected to your microcontroller, usually through a GPIO port. You read the signals that are coming from there. You look at the data sheet, you convert those signals to real life characteristics. So to give you an idea of some of the sensors that you can use, just some generic ones. I'll give you 3 examples. An FSR, so it's a force sensitive resistor. The way we connect that to an Arduino, it's very, very simple. It's just 2 wires, you connect them to the 2 pins and you put a resistor there. And as you can see in the code here, this is an Arduino code, and essentially you're just reading the pin that's connected to your resistor, and you pass the information that you're reading to your serial monitor to kind of get an idea of the changes in pressure. In one of the sessions I had, one of the students asked, "Please be good to kind of your steps," and I would say these are too sensitive, and the readings you would get from these are not good enough, so you can get a good characteristic of a gait or step, especially with the if someone's wearing long heels. Yes, Ian, you wanted to add something?
Yeah, we've actually got one of our local students working on using these analysis. It's possible to use them as long as you bear in mind what Savash has already said. They're not necessarily accurate, but if you want to pick up events that are happening, so you want to find out when the heel happens, because the sensor itself will react once that heel pressure happens, mark that is that point in the stride, and by putting multiple sensors across the insole of the shoe, for example, you can also tell when the ground by the change in that resistance. So you look for a change rather than an actual value. You can adjust the sensitivity by adjusting the value of this resistor, the 10K resistor, and that can allow for people's different weight. But they are in the things like gait analysis, but more for detecting events rather than measuring actual pressure because of the accuracy issues. That was all.
Yeah. And I think you're talking about the one that Ron is working on, where he's made like a inlay for a shoe with a bunch of these attached to it. So that's I think they become more interesting when you use these in conjunction with IMUs, which we're gonna cover in a bit.
And that's what he's
So yeah, another one, because lots of you are like doing some sort of temperature control or maybe humidity control. A very, very generic small temperature control sensor is a TMP36, and it's very cheap, like just a couple of dollars. And the reason I'm mentioning it is because it would be, if you just wanted to get some practice and see coming from a temperature sensor look like. As I mentioned, so with this one again, you're the changes in voltage, and you get a equation like this that I have over here and you convert that to actual temperature. The connection for it is very simple. You have your ground, your voltage, and the signal pin to one of the inputs of your microcontroller. And a very, very basic code, because a couple of people ask me how do you usually capture information from a sensor. So I myself usually just capture the information and send that to the serial monitor so I can read it. Later on, to implement a phone app, for example, to send the information wirelessly, Bluetooth or something, that's where I would then information to the serial monitor. You would pass it to your Bluetooth channel and capture it on your phone, or an RF transmitter and sender and receiver situation. So again, as you can see, these sorts of sensors, it's very easy to get something started. Essentially, we're just utilizing a pin, reading that, and converting that to temperature. Of course, Ian's favorite sensors, IME. To give you a very quick overview of them, they're essentially an accelerometer, magnetometer, and a gyroscope embedded on the same chip. And they usually, sometimes they're known as 9DOF sensors or 9 degree of freedom sensors. And the unique characteristics of IMU is they have these three separate sets of sensors, or they might have accelerometer and gyroscope same chip, and the magnetometer separately, still on the same PCB of your module, but offered it in that package. So parameter, what it does, it measures a linear acceleration in 3 dimensions. Of that, you can, and using a trigonometry function, you can get pitch and roll and these sorts of things. I won't go that deep into it. I'll post these questions in the board. So for those of you who want to go more in depth about these sensors, but it's not everyone has the technical background. You know that we use the accelerometer to usually pitch, yaw, and orientation in systems. And then we can also use gyroscope, get usually the rotation, because it uses a spinning rotor, and so depending on what axis you're calculating, you can use that. And of course, again, depending on the axis, you can use to calculate the angular velocity for that axis and see your results. Now, with any sort of sensors that you end up working with, it's usually the case that the raw signal capturing from the sensor might need that extra bit of processing to be able to actually do stuff with it, analyze it further, and that's called signal conditioning. As an example of that, I'm going to show you three. There's linearization, amplification, and filtering. I have some before and after pictures here, so you can see when applying those methods to a signal that linear, how does that look like? So this is linearization, amplification to usually give the signal a gain so we can see it a bit more clearly, and of course the important one, filtering, which is usually used to if we have any drifting issues, and using low pass filters, high pass filters, complementary filters, and those sort of things. So, excuse me. So, it might be interesting to give you an idea of some of the interesting projects we're doing here at Keratin with IMUs. This is one that my wife's actually working on, and this is for tracking white. This is an older generation of it, but it's essentially an Arduino Pro Mini, an IMU sensor 9159, and 19. It's actually using the new one, which is 9250, and a Bluetooth transceiver, kind of all sandwiched together. And as you can see, this is just a prototype. Everything is like literally sticky taped together. And later on, when you actually get to your product, go and design your own PCB, have everything in there. But as a prototype, this is usually you get open boards and connect everything so you can test your signals and show your proof of concept. See if I have it in the next slide. Yes, this is connected to a one leg and a wide cane, and the idea is using that we can track movement, and we can use it as a training system to kind of remotely teach people how to use the wide cane, and especially if they live in remote areas, this is going to be very useful for them. Another one, this is something I'm working on myself. Another interesting look. So I'm using these sensors to capture the wrist movement of children with cerebral palsy. The red board and the blue board. So the blue one, that's an MPU 9150. Again, I'm using the new one, 9250. The red one is an RF transmitter. The green one is something that one of our other PhD students worked on because they wanted the sensor to be smaller because they wanted to use them with TVs. They reduced down the size of a Arduino Pro Mini to that small size, but as you can see, it's still a bit chunky. It's still a prototype. So the next generation of this sensor is gonna be everything gonna implemented on the same PCB. Apologies for stopping. Bit of a cold. Now, there's an.
You can't afford to get sick.
No, don't worry. I'll still show up for work. Another one that we have here. So, an example. So, usually testing stuff. If I need to anything wireless, I want to show you As a prototype proof of concept, it's literally an Arduino, a sticky tape to a receiver, and I connect that to my laptop. And let me see if I have a picture of the receiver. So this is a very simple program that I usually use with these sort of tests that I do. It's a serial board reader writer. You just connect your receiver and it reads the information that's coming to the serial monitor. So information coming in from my IMU sensor. As you can see, I'm not using the magnometer. Usually that's prone to electromagnetic interference. So I use the accelerometer and the gyroscope for my calculations. Here's an example. So that information stored to my laptop. Then I use MATLAB to draw a diagram, and you can see a comparison between a simple wrist movement of doing a stop sign with left one with cerebral palsy. You can see the maximum angle was about 25 degrees, because that would have been the maximum angle they could have raised their hand, and the other one is much higher. All right, so I also just wanted to show you some of the other types of movement might look. I just wanted to test some rapid and slow movement of the hands using IMU sensors with different axes. You can see that here. One slower hand movement. I just want to show you how the IMU sensors can usually drift over time, especially seeing that z-axis over there. So that's why we need that filtering and signal conditioning move forward. As I said, the evolution of now going from that prototype idea to actual device, this is what I'm currently working on, is putting all of those sensors on the same PCB and communicating with them. So how about I stop for now, get to some questions, and
Do you have any questions? Ones you had last week when I was doing the recording, I heard you had a couple of about networking things. Can you remember what they were?
yes, so with networking things, there is, I don't have them here, but I just showed these ESP32 LoRa modules. So, well, if you look around, you can find them for much cheaper, but 32 LoRa modules, very popular. They usually have a LCD there as well, and they're based on ESP32. They've become popular because they have a Wi-Fi Bluetooth module embedded at the same micro. And as you can see, there's, even though it's not an Arduino, but there's an Arduino core available for it, so you can just program it using Arduino. This could be a good option. And there's also the other one. There's a shield that's just for Arduino. Or
We use the Dragino a lot.
Arduino, yeah, that's the one I was going to show. This one. It also has, I think, a bunch of, it has a GPS and a temperature sensor as well. So, not, they're essentially extensions usually to a board that have a bunch of new peripherals, like in this case, a LoRa module and temperature.
Just to refresh people's memory, LoRa's a very nice protocol for communication under certain circumstances. It operates at the 900 megahertz range, or 800, depending. Make sure you buy the right band for your country. But in Australia, it's the 900 megahertz. Very useful if you've got very low data rate requirements. It's only in the hundreds of bits per second, but because it's in a lower frequency, it's very good, number one, for long distance. It's quite easy to get 5 kilometre coverage or inside building because the lower frequency penetrates concrete and brick quite well. But it does have that disadvantage, very, very low data rate. But if you're just checking things like temperature sensors or humidity sensors within the building, that terribly often, it's very small amounts of data and LoRa can handle it. Problematic to set up, only because it's new and people aren't. But it's worth a shot if it suits your application. The other option with it is it's extremely low power as well. So if you've got battery-powered devices that you want to be able to run for long periods of time, LoRa is actually quite a good solution there too. Has a specific question relating to their project? Would be nice to hear from you.
I see Carlos here. If I'm not mistaken, I was just watching your smart shower with you. If you wanted to maybe about that a little bit.
I like that one. It's a very interesting a device because they do not look safe as they are.
Yes, that's what I was thinking.
Can you hear me, guys? Okay, well, hello to everybody. I'm sorry I got late, but I just arrived from work. The thing is that here in my country and many other countries in Latin America, we use these devices, the shower heads that we termoduchas in Spanish. I was asking in the Red Cross committee, and we don't have any recent incident with those devices, even they seem to be quite dangerous. In fact, I here at home we have one of those, and we have used them for many years. I mean, different of them, of course, and we have never had any incident, not even a small electric shock. I was checking with in another YouTube channel, and I found that due to the high resistivity of water, it is very unlikely to receive an electricity shock while opening and closing the faucet. Well, the thing is that these devices have the inconvenience that they have a very fixed setting for how much power, electrical power, they consume, and I'm sorry, they have a mechanical switch that is activated with the pressure of water. So this has convenient that you are unable to modulate the amount of electrical energy you need to heat the water. And if there are changes or fluctuations in the water pressure, the temperature can go up or down, or even the device can disconnect. So it's very uncomfortable. And the thing is that when you open it, it is too hot, you need to increase the water flow, so you end up wasting more water just to decrease the temperature. And this has always been a concern here with the people I know, and also here at home. And I came across with the idea of trying to design a device that is able to modulate the electricity power and take into account the water pressure, so it keeps the temperature of water very stable, no matter how much water flow you have in the, well, of course, inside a reasonable range of water pressure or water flow. And the thing is that I also thought that it would be very interesting if we would be capture the data related to how much water, how much electricity is consumed by this device, and even having the ability of identifying the different users to make adjustments if you are worried with the monthly bill of electricity and water. And also if you are worried about preserving natural resources such as water and electricity. That's it. That's the device.
It's a really interesting project, and that long-term data capture could be useful as well, particularly if you look at like notifying the water authority that the pressure is dropping over a range of buildings. You could then tie that into a map and look for a fault, such as a leak, if the water pressure within a group of flats start to drop. Sending it out to really interesting as well.
Yes, in fact, Professor, I had the idea, as I told you in an email, that be kind of modular in respect on how it is designed. So the individual components that measure water flow and electricity consumption can be separated and be used in different parts of the house or in a complex or building with different apartments. So the user can keep track of water consumption and electricity consumption in different places, such as in the kitchen or in a workshop they may have, or when washing dishes or washing clothes also. And I didn't thought of the idea you just mentioned, but it sounds very interesting because it also helps provide a better maintenance solution to a building or to a house complex.
Yeah, and you could at a later stage look at extending it even further so that it ties into the renewable energy. So if we've, say, a block of flats with solar panels on the roof, you know what your power usage is for the whole and other things. And if your battery storage is low, but you normally have a shower at this time of day, you go and borrow some power from your neighbour who doesn't use electricity at that time, and you repay that power at a later date. So you look at predicting who's got power you can borrow from and share it across the complex.
Yeah, that's a very interesting approach for this IoT idea.
It is a good
and
one.
based on that, I can even think of more and different applications for this kind of sensing and reporting device.
Industrial application would be interesting too. So if you've got a laundromat, for example, a company that does large-scale hospital-type laundry, they'd be very interested in something like this to watch their consumption and water pressure as well.
Exactly, and one market sector that I was thinking of was of the hostels and small hotels here in Costa Rica, and also bus stations that offer the showering service. So they can do, for example, they can have a better insight of how much water and electricity are they investing in this, so they can calculate their costs better. And depending on the usage and of the policies of the establishment, this can help to establish a fee for the use of these services.
Pay for the amount of hot water you use rather than a fixed fee.
I'm sorry, I didn't understand.
Pay for the amount of water you use rather than charging everyone the same. So a 5-minute shower costs you as much as a 2-hour shower.
Exactly. That's the idea, to have a better insight on how much is the cost, how much is being spent, and how much will be the reasonable fee to charge in these services.
That's good. Okay. Anyone else got any questions? Would like to talk about what they're doing? We'd like to hear what you're doing.
I also have a couple of examples of approaches to kind of playing around with sensors and microcontrollers. There are these kind of sensor packs that some companies provide. So this one is a sensor tag by Texas Instrument. What they basically there are a bunch of, say, they're like this specific one. It has an IMU 9250, it's a pressure. It has a pressure sensor. It has a sensor. So a bunch of sensors in a small package, and they offer. So here's a view of the back of it, and they offer a phone app for it as well. So we can monitor those movements directly on the phone app. What's interesting about these sorts of sensors and playing around with them is they offer the hardware and the software both as open source. So if say you're interested in the way they set up their software, but you just want to use a temperature sensor, you can then go look at the PCB design of their sensor tag, remove all of the components that you don't want, not physically just designing your own PCB, offer the hardware, and kind of modify their app to just show that temperature or the sensor you're interested in. Another one that I'm using for my own project is this Nordic semi thing. It's another sort of sensor tag with a bunch of sensors on top of it. This one actually it has there's a software for it. It's a bit more robust. So here's a screenshot of the software because it does have a 3D module of the movement. Temperature, there's a speaker, there's a light. So there's lots of extra stuff on top of it. As a result, these tend to get a bit more expensive, around the $50, $60 range, but they could be interesting, especially if you just wanted to play around with a bunch of different types of sensors. Then they come in a small package. As I said, again, they have these apps that you can play around with. And again, because they're offered as development boards and usually open source devices, you'll have access to the source code of the software and the PCB layouts of their board. So there could be other directions you could take your designs.
Okay. Does anyone want to talk about their particular project, what they're up to, how they're going with it, if they've got any issues with it? We've got a few people still on, so we'd like to hear. Going through all the videos right now, along with others. I'll comments up over the weekend as well on the videos. We should have those marked back to you hopefully by Friday your time. Minutes left to chip in.
In the meantime, how about I show you? So this is what I went through with one of the other sessions we ran. Say I wanted to work with MPU 9250 and I wanted to get an idea of how to get source code and how to get started with it. The site I usually use is this Core Electronics store. I'm not suggesting them to just purchase stuff from them, depending on where you are. The shipping might be expensive, but usually under their products, they have lots of tutorials. Like here, there's a getting started guide with questions about what it is, talking about different protocols, and talking about the pin maps. So a more detailed version of just a pure data sheet. And of course, they offer, as you can see, connection guidelines and even source code. So, or if you have, if your board that you're looking at has an Adafruit or Spark One kind of development board for it, this would be a good place to start.
One of the things we will talk about in a later session is how to do the PCB. Just as a bit of a chat, it's not actually part of the course, but some people have been asking, how do you go about it, what tools do you use, that sort of thing, and we'll run through a couple of the professional ones, more on the free fritzing that appears on Savash's video is another good for drawing out how you're going to do things. It's not as nice as Tinkercad, but it's a download program, so you don't actually have to have an internet to use it, I think, from memory. So it's an alternative. We'll go through a little bit on PCB design, which packages to use, for designing that, etc. Probably in the last weeks. Got 15 minutes left if anyone wants to jump in. That's what they're up to.
Question.
Sure, go ahead.
This is not particularly related to my project. I'm just asking this question out of curiosity. But is there a sensor that can measure seismic activity? Like, sensitive enough to measure like human footsteps, or I don't know, like human activity, animal activity,
Ooh,
something like
it's
that
depends on
sort.
it's more for the conduction of the vibration through the soil. The trouble with soil is it tends to dampen things fairly quickly. We have a from echo, so something like sonar radar, and they have a small explosion and they measure the seismic coming back. There is no doubt some. You want to have a quick search for Savash? Not good, but that's more on the soil than the ability of the sensor. Picking up animals. How would you pick up animals? If you weren't going to put down plates so that when they walk across a matting or a plate, then I think you'd have a lot of difficulties simply because a small animal won't make much of a vibration through the soil. Large animals you could pick up, horses, cattle, that would be possible. And you could use a pressure sensor or even an IMU would be able to pick up a very sensitive IMU.
I was expecting more like an indoor application.
Different altogether,
Walking
yeah.
on hardwood floor, my footsteps on the hardwood floor, indoor. More audible.
Quite easily. I've got hardwood floors in my house, and I can hear my dogs wherever they are. But mind you, they're big dogs, being Great Dane and Irish Wolfhound. But you can use audio, filter out the range, and characterize the audio from that particular type of animal. That's difficult, but it's possible. Or you could look at the vibration in the floor. With concrete floors, again, it was a problem, not the sensors. I don't know the vibration, but get audio, which you may be able to pick up. A seismic sensor. Not exactly certain how it works, but
Yeah, just search, and it is actually on the IoT store.
quite intense.
Yeah. Precision.
Acceleration. Yeah. So they're just using accelerometers. So
Yeah.
interesting problem. We've looked at character sounds for different applications. It is rather difficult and very precise sounds you're looking for. One we were working on was for hearing impaired drivers. So we were looking at picking up sirens, horns, brakes, those sort of sounds. And because with automotive standards, you've got a very set range for the sirens and horns that you're allowed to use. We would have a level that we would need to be able to pick up if the vehicle was close enough, so the horn's loud. If it's quiet, we just ignore it too far away. And we could actually detect set frequencies that are used within the horn range. Where it falls down, of course, is if people add aftermarket horns and they don't match the frequency. But it gives the direct, using a microphone array, we would pick up the direction of the sound. So we could alert a deaf driver sounding at the left front of the car.
I was actually curious whether there is an alternative method for determining the presence of humans or animals in the house. So the robots can, tell during which time period humans are most likely out of the house working, or dogs are, out of the house,
You can
working.
use vision. Cameras are very good for that because you can classify an animal's shape simply by not being upright, and a human as being upright, so different shapes, and filter out furniture because it doesn't move. Or if you've got dogs like me, they don't move either, but it would be a vision system would have to do this.
Would it be capable of telling, humans apart from animals or objects or
Because
robots?
a human shape, a human object, a human very different shape to an animal object.
Mm-hmm.
It's a rectangle, pretty much a rectangle squarish, and limited height. You might have a problem with the child. So all you really need to do is look for those sort of, use a fairly straightforward machine learning algorithm to categorize either as animal or by shape, not by size. And is it human? Is it animal? It's not moving. It's neither.
Okay.
Savash, she was talking Wexer, was it?
Was it V?
Or TensorFlow to actually develop that system without having to do any real programming yourself. Okay, sorry. Wellington University. I think it's W.
This one? W?
It's W, right? Not V.
Was
Yeah.
Okay.
Have a quick look. Flow's also a really good one for this.
Yeah, Vecca.
Okay. Yeah.
Weka.
Completely open source, free to. Somebody said best thing to come out of New Zealand.
Machine learning software in Java.
GNU public license is the key to it. Anything you develop with it, you're not allowed to copyright. So just be aware of that. But it also means that anything you develop, you don't have to pay anyone else for.
I think Valerie mentioned in chat that something about.
Not chat up. Should put that down.
R also came from New Zealand. So there you go. Two things. They're good.
Thank you very much. Thank you very much, Professor.
No problem.
Actually, bookmark that for my own research.
Well, if there's to ask a question, or we might close off now. I'll hang around for a few, just in case somebody wants to say something. I'll stop the recording. But thank you all for coming along. Thank you, Savash, for taking over. I was away last week in Canberra, our capital city, lovely place. So I asked Savash to run days, seminars. I thought we'd keep it all the same and have him do it again. Great. Good on you, sir. Thank you, everyone. We shall see you in another 2 weeks. We'll have an interesting little chat about, hopefully it'll be about GIS, mapping, how to use spatial data within your IoT application. I'm trying to get David, we can prepare something for us on that as a start, and then we'll go into the discussion of your projects afterwards.
And I also have a couple more samples of ESP32 up because I had quite a few people ask me about those. These are some of the ones that I've been about. There's other one. There's the Spark Fun ESP32 thing. So these two are fairly popular boards. You can find them for much cheaper on AliExpress from some more manufacturers, but these ones would have more support behind them, so more more sample code and more tutorial. If you wanted to get something and you wanted to play around with the because these are fairly popular because of their Wi-Fi and Bluetooth modules that they have on them.
Hi guys, hi professors. Here is Rafael from Brazil. I have some question regarding my project need to send some data to the cloud. I already made some tests with the Raspberry Pi, so it's working. And now I need some help, or at least some guidelines, how to process this data in the cloud. Is there someone who can help me?
Valerie, this one's
Valerie.
for you. Yes,
Okay.
she's on today, so hopefully she hasn't disappeared quite yet.
Yeah, no, what I will do, I will just write something and I will talk to her.
Yep, okay. Send it to the IoT Capstone email address, subject.
Okay.
And I'm sure she'll get back to you fairly soon on that one. But Valerie
Yep,
is
that's
definitely our
fine. I am here.
person. I thought you might have lost your tab again.
Okay.
If you send an email through, I'll have a look at that. Give as much information as you can about your setup. Things you may or may not want to include in the solution as well.
Okay, good. It's a simple solution. It's just to send the MQ2 information to the cloud, and then I want to do some like APIs in the cloud. It's something simple, but I'm just struggling a little bit.
What cloud platform are you using?
From Microsoft Azure. If someone suggests some other things easier, I can use it too. There's no problem.
Leave that to Val to work out with you.
Okay.
Val is now our AWS expert as well, along with Sebash.
I did not to try AWS, but I can try. No problem.
To Val about it.
Okay, good. Thank you.
All right. Well, we've come up to just about 9 o'clock. As I said, I'll hang a couple of minutes if anyone wants anything else. But thank you, everyone, and see you later. Stop the recording now.